Dear students, in this video we will discuss how to evaluate integral double integral over the region R sum x plus y dy dx, where R is the region bounded by the lines x equal to 0, y equal to 0 and x plus y is equal to 1. So here in this particular problem, the region R is mentioned that it is bounded by these three lines, but the limits of the region are not given, so we need to find the limits. Once the limits are calculated, it is very easy to find this double integral, and there is a separate video in that evaluation of double and triple integrals I have already uploaded. You can see in that one. So right now let us see what is that particular region. So let me call that I. Let I is equal to double integral over the region R x plus y dy dx. Now R is given by, where R is given by x equal to 0, y equal to 0 and x plus y is equal to 1. Now let us see how is that region R. Now I'll write it. I'm sorry. So this is x-axis, y-axis. Now x plus this particular x equal to 0 is nothing but y-axis. So this is x equal to 0 and this x-axis is y equal to 0. And if you look at x plus y equal to 1, x plus y equal to 1, I'm dividing with 1. So that is nothing but x intercept is 1 and y intercept is 1. So if I take this as 1, for example, this much is 1, this is 0.5, of course, understood. So I get 1 here. Now what I do is I take up a straight line passing through these points. Now the equation of this line is x plus y is equal to 1. I can write as y is equal to 1 minus x. I can write as x is equal to 1 minus y. All this possible, okay? So the actual guiding equation is x plus y is equal to 1. Now if you take up any point, this region, actually the region is this region. So this complete region we have as the region R. So this is region R. Now I'll change the color of the pen. I'll say that this yellow dot is moving, suppose, in the region. Then what is the value of x here? The value of x is 0. The value of x is 0.1, some 0.2, 0.3, 0.4, like that. So the value of x is running from 0 to 1. So the limits of x are, limits of x are 0 to 1. It cannot go more than 1 because it has to go only up to here. But one thing is that, let me say about this point, that is 0.9. When x is 0.9, y can go only up to this height. And when x is 0.1, that y, that point, yellow point, can go up. Now when x is 0.1, y can go up to this point, and this point is roughly 0.9, exactly 0.9, because this point is 0.1 comma 0.9. as it is on the straight line, that total value of x and y should be equal to 1. X plus y is equal to 1. So when x is 0.1, y will be 0.9. When x is 0.9, y will be 0.1. When x is 0.5, I will change the color. I will show with a different color. I'll try. Okay, when x is 0.5, then that dot can go up to 0.5 roughly. So this is 0.5 comma 0.5. What we have understood, So the height of that particular y, this variation, okay, this variation, this in this direction, that y is changing. Now this is like a strip parallel to y axis. So when we write a strip parallel to y axis, y limits will be written. So limits of y are starting from 0 but ending at 0.5. That 0.5 is nothing but the x value. So when x is 0.9, that y is 0, x is 0.9, y is here, I'll write it, x is 0.9 and y is 0.1. This 0.1 is nothing but 1 minus 0.9. The total of these two is 1. So what should be the y value? Y should be equal to 1 minus x. So if I take a strip parallel to y axis, that strip is starting, all the strips are starting at this and ending at this one. So the thing is, it starts at 0 and ends at 1 minus x. So if x is equal to 0.5, it starts, y starts at 0 and ends at 0.5. That is nothing but 1 minus 0.5, this 0.5. And when x is 0.9, y starts at 0. If you take a strip parallel, now this strip I am taking parallel to y-axis. I may take this strip parallel to y-axis here. I can take this strip parallel to y-axis anywhere. So wherever I am taking, I have taken 3 strips with this color. Okay, with this color I have taken 3 strips. Okay, I'll make this also with that one. So all these strips I made with this color. If you look at all the strips are starting at this base, that is y is equal to 0. But with respect to y, their ending is different. This first strip is very long, second strip is somewhat less, third strip is less, fourth strip is less, again there is a small strip. As you go on the x-axis, as the x is increasing, the value of y is decreasing. Therefore when x is 0.9, y will vary from 0 to 0.1 only. When x is 0.1 in the beginning, then y will start at 0 but it will end at 0.9. This 0.9 is 1 minus 0.1 and this 0.1 is 1 minus 0.9. Means what? Whatever x value is there, y starts at 0 and it goes up to 1 minus that x, as you have seen in all these cases. So now let me not write all this. This all details are for you to understand. So simply what we do is, let it be there here. So I come up with the point. So the limits of the region, I'll write it directly now. Limits of R. Now x is varying from 0 up to 1 and y is varying from 0 to 1 minus x. This is so simple. From x plus y equal to 1, y is equal to 1 minus x. It starts at 0, it ends at 1 minus x. So therefore that I will be equal to integral x is equal to 0 to 1, y is equal to 0 to 1 minus x. Now let me see what was that problem. That problem was x plus y dy dx. X plus y dy dx. Now this is nothing but integral x is equal to 0 to 1. You have to integrate first with respect to y. Inner integral is, inside integral is with y, and then afterwards we will go for x outside. So let me now, okay, so now we are integrating with respect to y, treating x a constant. So x into y will come and y integral is y square by 2. So the limits are from 0 to 1 minus x dx, and you can continue this by writing the upper limit and lower limit and simplifying. So I hope you understood. So how to take the limits of the region. Now let us practice about some more regions. So if the question is evaluate integral R, some function is given. This function is not important for us. Okay, dy dx or dx dy, anyway, where R is the region bounded by the lines, x equal to 0, I'm sorry, y equal to 0, I'll take it, y equal to 0, x equal to 2, and y is equal to x. Now in this case, this integrand is not important. What is important is what are the limits of the region. So first of all, I will draw the region now. That region is y equal to x is a straight line passing through origin and making equal angles with both the axes 45 degrees here. This is y equal to x. Y equal to 0 is x axis, and x equal to 2 is a line parallel to y axis, because y axis is x equal to 0 and it is parallel, that is x equal to 2. Then this point must be 2 and this point is 1, suppose. Now the domain of integration, the region of integration is this blue dotted region. Okay, this complete region, this is the region. What we are now going to do, we are going to write the limits. So we are having two chances, two approaches. First, take a strip parallel to y-axis and then expand it, or first take a strip parallel to x-axis and then expand. Both the ways are possible. Sometimes one way will be better than the other way, that situation demands. Okay, now what I am trying to do is, I will just simply take a strip parallel to y-axis. If you want better understanding, think, don't draw these two strips, think only 3 more strips like this parallel to y-axis, and then this, they all start with 0. So you write that y is starting from 0. What is the end of that one? Then this line is y is equal to x. So what is the boundary? So if x is 0.4, then y will go up to 0.4. If x is 0.5, y will go up to 0.5. If x is 0.9, y will go up to 0.9. Means y goes up to that x, whatever x you have selected. And that x is moving here, that point. That point is moving, or the what you say, that strip is expanded. So by expanding these strips, what is the x values? That x should start from 0 and x should go up to that 2. So x goes from 0 up to 2 and y depends upon x, that is y is equal to 0 to x. So therefore that integral I will be equal to x is equal to 0 to 2 integral y is equal to 0 to x, whatever function is there, that function dy dx, then first integrate with respect to y, then integrate with respect to x. This will be the situation. Let me show you one more region, so that just I'll write the region and then just end up the point. Suppose if the region is here like this, I'll take a different color. This line is y is equal to x plus 1 and this is the region. Suppose this is the region and this is 1, 2, 3. Then what are the limits now? Then I will take up a strip parallel to y-axis. Better generally we take like this. Now this strip should be expanded to get the complete blue region. So y starts with 0 because it is starting with 0 and it is ending at this point. This point is nothing but x plus 1, y equal to x plus 1. So y starts from 0, ends at x plus 1 and x starts at 0 and x ends at 3. Suppose we want to write with respect to a strip parallel to, okay, let me change the color. Suppose this is the region, and suppose this is the region. I want to span this region. Then I can take a strip parallel to x-axis or parallel to y-axis. I have shown you the examples with parallel to y-axis. In this I will show you the example parallel to x-axis. So you can take a strip parallel to x-axis, and then you can expand this one to get the complete blue region. This is the region R. This is region R. Region R. So what is the starting of the strip? This is the start, and this is the end. So A is the start, B is the end. So if you take up any strip, think about some general strip, some different positions. You just think about a strip parallel to x-axis. It starts with 0. So x is starting at 0 and it is ending at some value. But what is this line? This line is nothing but y is equal to x, means x is equal to y. So x will end at y, and y is starting at, what is the value of y here? For example, I am taking as 4. So if it is 0, 1, 2, 3, 4 like this, so y will be starting at 0 and ending at 4. So 0 to 4. I hope you understood. So this region is written as this way. That same region can also be written in this way. Okay, I'm sorry. Suppose I'm taking 1, 2, 3, 4, 1, 2, 3, 4. Then that same blue region I'm taking again. I want to get this region, then I can take a strip parallel to, I have taken a strip parallel to y-axis now. So this should be expanded. Now in this case, the limits will be very different, you see. Same region we have, but we have decided now to we have decided to take first y then x. So y limit should be written now, because it is parallel to y-axis. That strip is parallel to y-axis. Y limits to be written, then x limits. Now this line is nothing but y is equal to x. So x equal to y or y is equal to x. Now the starting point is different, you see. A is the starting point, B is the ending point. Now if I take a strip parallel here or here, the starting point is different, and the starting point is nothing but x. So it starts at x and ending point is same, you can see. The ending point is 4, so it ends at 4. And now if you take this strip is having some x value here, this strip is having some x value. So x value goes up to what? Maximum this one, and y equal to x means x should be 4 here, because y is 4, this point is 4 comma 4, this point is 4 comma 4, therefore this point is 4. Now so x varies from 0 to 4. I hope you have understood. So this is how we decide the limits of integration. Now if this region is given, we can write as per this. This is one order of integration and this is another order of integration. Let me say with very much emphasis here. So this is one way and this is another way. So this is one way, this is second way. So it is our choice, we can decide any way, but in the examination if it is given change the order, so one way it will be given, we have to do the other way. So I hope you understood how to decide the region, how to decide the limits of the region. Thank you.